All right, well, first off, thanks for everybody for coming during lunch. I know it's a bit of a challenge. So quick question, how many people in the room write and submit kernel patches on a regular basis as part of their job? How many people have submitted at least one patch for the kernel? Okay, how many people have worked with people who've submitted patches for the kernel? Okay, pretty much everybody. All right, so good. We have a good group of people in here. So I'll be talking about how we at Red Hat are trying to change kernel developer workflows with CI. And so my name is Major, and I work on a team at Red Hat called CKI. We're trying to get people to name it Cookie, but it's a work in progress. I'm from Texas, and I told somebody about this here the other night, and they asked me if I owned a horse. I don't own a horse. I haven't ridden on a horse ever, actually. I do ham radio. Does anybody do ham radio? I know we got one. Two. Okay, great. All right. If you don't, it's the best, most frustrating hobby in the world. And then I also run icanhasip.com. So kernel development is difficult. It's a challenging project to commit to. It's not like your average Python project or Go project or anything like that. When a kernel breaks, you lose data, or a machine goes down, or a car doesn't do what it's supposed to do. So it's complicated. But being a kernel maintainer is also complicated work, because you get these patches from people. You're trying to make sure that your subsystem or the tree that you take care of is as stable and has the best performance possible, but everyone wants to change it all day long. And some of the things they send you are fantastic, and you're going to see great benefits, and some of the things will destroy your part of the kernel, and then eventually have someone yell at you later on. So I grabbed these numbers. I think it was from 5.1 to 5.2, but for one release, over 17,000 changes were merged, and they were written by over 1,700 people. And about 150 to 300 of those people, that was the first time they had ever submitted a patch to the kernel. And at Linux Plumbers, a couple of weeks ago, Dimitri from Google did a talk, and based on his estimation and their testing in the kernel, they believe that there's approximately 20,000 new bugs with every mainline release, which is pretty scary. And even if that number seems like an order of magnitude too high, 2,000 is still a lot. So in the end, a lot of end users that use machines expect Linux distros to take care of it. So folks who work on Fedora or Red Hat or SUSE or Debian expect them to take care of these bugs, but it's too many. It's massive. So if you're a kernel developer and you say, okay, I fixed a bug, I'm ready to send this thing out, how do I test it? Like, how do I know if I actually did a good job? So you start asking yourself some questions. You think, okay, well, how long is it going to take if I have to compile this on my machine? Maybe I'm compiling it on my work laptop that I'm doing everything else on. Is my laptop going to work for anything else, or is the fan going to spin up and I can't get anything done? You might ask yourself, well, how do I trigger the bug and test the change? So someone reported the bug to me, but how do I actually get the system into the situation where the person found the bug in the first place? And so then you think, well, wait a minute, does my fix make performance worse? That would also be a problem. If you think about Spectre and Meltdown, that was a large challenge to deal with. The next thing you might ask is say, hey, does my change cause problems on another architecture? So we see this quite a bit where someone will try to improve something on x86 and destroy performance on ARch or Power or something else, or vice versa. Then you might say, wow, does my change create a vulnerability? I fixed it, but in fixing it, did I cause a problem where someone can crash the machine or steal data or something like that? And then you have to say, well, do I have the right hardware to test it? So let's say you got a bug. Maybe you need a specific network card. Maybe you need a specific ARM system or power system to be able to test it. And sometimes it's really easy. You say, okay, well, this thing is like $5. I'll just order a couple of them and I'll go try it out. But then sometimes it's a little bit more difficult. So if you're working on an S390 issue, getting a hold of a mainframe is not exactly something you can get on Amazon. And then even if you do have the hardware, do you have the time to maintain it? Do you have the skills to maintain it? Keep the OS up to date. When drives break, replace them. Memory sticks break, you have to replace them. I love Office Space. How many people have seen Office Space, the movie? If you haven't, oh my gosh, it's fantastic. And then finally, for me, this is the question I always ask. Do I have an SMTP server set up properly? Every time I use get send email, I'm missing something. Like something's not running or I've got something misconfigured. Maybe that's just me. But Robert Love wrote a book called Linux Kernel Development, and at the very end, he talks about contributing to the kernel. And one of the things he talks about is when you send that email to the mailing list and no one says anything, which is apparently the worst response you can get. And so he says, if you fail to receive any response, try to discover what was wrong and resolve the issues. but didn't you do that already? Wasn't that the whole point of why you fixed the bug or wrote the patch and submitted it? If you send it and no one says a word, that's like the worst feeling in the world. I'd rather get yelled at personally. So the question we asked, and a lot of other groups are asking, is what if the kernel had CI, like many other software projects? If you go and commit to your average Python project or Golang or something like that, you'll find that in GitHub or GitLab, CI will immediately spin up and start linting it, and then start running unit tests, and then sometimes they'll even deploy it and run functional tests against it. And if any of those fail, you can go and fix those problems yourself before the maintainers even have to have a look at it. So there's several Linux CI projects that are underway right now that are trying to shed light on some of these problems. 0 Days from Intel, they're running a lot of tests across various VMs and hardware, a lot of user space tests. There's CKI, which is us, also Kernel CI, which is part of Linux Foundation, is running a bunch of tests. We got LKFT from Linaro as well. And then Sysbot is a very interesting one from Google. They run a tool called syscaller that looks for common coding issues like use after free or buffer overruns, like all these different things you're going to run into in the kernel, and they find a lot. So we got started in 2018. We test internal kernels, so the Red Hat Enterprise Linux kernels from RHEL 5 and up. We also test some real-time kernels and some other specialized kernels that we have. We also do testing upstream as well. And so our testing is triggered by different events. So if the Git repository changes, like let's say Linux pushes a new revision to mainline, we'll start testing. If new patches are sent to a mailing list or the Quilt patch list for a stable kernel changes, we'll go ahead and start testing. And then also internally, we have an RPM build system. And when that one finishes, if it's a kernel, we'll go ahead and test it as well. And so it's a pretty simple process. We take patches from wherever they come from, and we merge them in and create a tarball with the repo. And as part of that tarball, we also bring in the kernel configs as well. So we use some, usually the kernel configs are a little bit oriented towards the Fedora distribution. So those are the ones that we pull and use. From there, we take that tarball and we throw it into Openshift, which Openshift is a container management platform, software development platform. From there, we compile the kernels inside containers. And at the end, GitLab will pick up all those artifacts, all those built kernel artifacts for us. And then that step will be done. Then we go to test it. And so we have a system called Beaker, which does two important things for us. One, it provisions all these crazy amounts of systems we have, everything from a laptop to a traditional Dell x86 server to an ARM server to mainframe, whatever it is, it provisions it. And the second part of what it does is it works very well with our test harness, and so it deals with exit codes and logs and all that stuff and makes sure it's all picked up. Finally, once that's all done, we take everything and GitLab picks all those artifacts back up for us. And the last step is to generate a report. And so when it comes to making a report, we have to take all the builds that we did, all the merging that we did, all the tests that ran, including those that misbehaved that we have to figure out, something else went wrong besides the test. And we take that and we send it out. And so we get it to the mailing list, which will get it to the patch submitter and the kernel maintainer. But we also have test maintainers inside of Red Hat. So we have folks that work on LTP and some of these larger test suites. And we send them a copy as well. So when something breaks, they can jump in and say, oh, no, that's a test problem. We're going to get that fixed. So you might be saying, okay, well, what actually gets tested? So at the moment, we're running over 50 different tests and test suites. And when I put the slides up that are available, you can click it and it'll take you straight to our group of tests there. So we test some things that are very hardware oriented. We test some things that are specific to certain kernels, like real time. We've run test suites like LTP, which have thousands of tests in them that do all kinds of stuff on a system. And we take this list of tests and we target them towards the kernels that we're working on. So depending on the kernel repo that it came from, or maybe the content of the patches. So someone, let's say someone submitted a change that, I don't know, changes the way packets get into NetFilter. We're probably not going to run any InfiniBand or RDMA tests, but we'll go and run all the networking tests we've got to make sure that nothing has been broken in there. And the same with the trees. We're going to run different tests on NetNext than we would run on the RDMA subsystem tree.
So is that targeted testing done automated?
So you had a question about targeted testing?
Yeah, so how do you decide, or I understand how do you decide what to be run in terms of the targeted testing, but is that selection process automated?
Yes, the selection process is automated. So ahead of time, we will say, you know, if it's this kernel repository, these are the tests we care about. And then we'll also say if the patch is changing files that are in these particular directories or these particular files, then we'll add on these extra tests. So case in point, we have one where it's like, if certain things are changed within the RDMA part of the tree, then we'll go ahead and trigger RDMA specific tests on hosts that have, you know, all the hardware in them to test out that part.
So all this information is kind of metadata, which is part of CKI.
Right, right. So right now, the database that has all that is internal, and we want to make it external. It has a few like internal things that we need to kind of make look better and take out some of the nasty stuff in there, but we want to upstream it because we think it would help other people understand which tests to run for a particular patch.
Thank you.
So if you're a kernel developer, you say, okay, well, what do I get? This all sounds good, but then in the end, what comes to my inbox? So first off, what we do is we send an email, and this is a sample of one of our emails. We love emojis, so we put emojis everywhere, even in the email. And someone argued with us and said, you don't put rich text in an email. And I said, emoji's not rich text. It's Unicode. So that was a fun argument. So inside the test, we tell you exactly what we did, what we cloned, what we merged, how we built it. We give you links to the build artifacts. So if you don't want to go do it yourself and you don't want your laptop to catch on fire for half an hour, you can just download it and run it in a VM. And then we also link you to all the tests that we ran. So if one of them failed, you could say, okay, wait a minute, I'm going to go grab that built kernel, throw it in a VM, grab the test, and you can run it again yourself. And so time-wise, if you submit patches and they don't merge, or we can't find anything to merge them onto, you'll find out usually in 2 to 5 minutes. If your kernel fails to compile, you'll know within about 10 to 15 minutes, and then all the tests are generally done in less than 5 hours. So you'll get that input back in your inbox or sent to the mailing list. And so this graph came from a talk that was at Linux Plumbers in Portugal a couple of weeks ago. And it's talking about the amount of ignored patches that are sent to kernel mailing lists. And right now it's hovering at about, I think, 2.2% of patches are ignored that are sent to kernel mailing lists, and it's been decreasing. And so there were some discussions in the audience when it was going, and some people were saying, you know, kernel maintainers are being more responsive and people are helping out. But then someone also raised their hand and said, hey, there's all these CI projects that are sending emails. Does that have something to do with it? And it was kind of agreed in the room that, yes, that is changing it. Now there's fewer patches that kind of go into a black hole and no one says anything about them. And so it's not all for the developers. We also want the maintainers to get extra context around the patches that are being sent to them. So as a maintainer, if you have a very busy tree, like the networking tree or something like that, it can be very hard to sit down and compile each one of those individually and review them individually and go through all that. But if you look at a patch and say, wow, the logic is sound, I know this part of the kernel, this makes sense to me, and an email comes through that says, hey, this patch didn't break the kernel in a horrible way, you have more context to understand whether you can merge that patch or not. And so what we want is we want maintainers to have that ability to be more efficient in their workflow and have more confidence when they merge something or when they go back and say, no, you broke something with the way huge pages work, let's say, and go back and try and fix that problem. So we want to help maintainers find issues faster, and Greg KH, is the maintainer of the stable tree, moves extremely fast. If you don't know, he's a machine. He's incredibly fast. And when we move faster than him, we really pat ourselves on the back because it's hard to make a computer go faster than Greg. Also, people do like to test us. So this was one where we came in, we got an alert that the boot failed across the board on a particular kernel, and we thought, oh no, it was early in the beginning and we thought we had screwed up. Someone had written a bad piece of code or something. And we go digging into it and we find this last line where it's a kernel panic and it says boot canary hit. And I've seen like 1,000,000 kernel panics in my time. I've never seen anything like that. And so we're all looking around trying to figure out what it is, and then a fellow in our office in the Czech Republic said, oh, I found it. Greg put something in the kernel to make it fail. And so then we emailed Greg, and we're like, what's going on? And he's like, okay, just making sure y'all are paying attention. So I got some gray hairs on that. In the end, we want developers to know that they're not working alone. There's systems out there like ours, and there's systems like LKFT that are going out there and building these kernels, testing them, trying to find any problems that could come from merging these, and let those developers know and let the maintainers know what should go in and what shouldn't. So what's next for us? What we really want to get to is scale up. So we want to test more trees, and we want to test patches that are getting sent to more mailing lists. Now, obviously, there's challenges with this because sometimes kernel developers don't agree with the idea of CI, and they like to send creative patches to mailing lists to cause problems with CI providers. So we're working through some of the security work required to get that done. We need some more architecture-specific testing. I talked with a few people about some ARch-specific stuff. Red Hat runs with, I think, what, 64K page size on ARch64, so there's some things we can do there. We also want to integrate more with kernel CI, and we've been talking with Dan and everyone who works on LKFT as well to find things where we can come together and work together and have more of a common front for developers and maintainers. Fewer false positives. That's one thing that we've received many times, is that false positives makes kernel maintainers chase ghosts, and we certainly don't want to do that. And then also data warehousing. I think that's something that all we talked about it in Portugal. We got most of the kernel CI groups together and had conversations around how do we make more value out of this data that we have. For example, how can we say, like, what is the quality of AR-specific testing across all kernel trees for a period of a year? That would be a valuable number. And so, yeah, you can talk to us. We have a blog. You can email us. We have a mailing list. You can find us on Freenode IRC. And then also on gitlab.com and github.com, we have the organization CKI-project. And so if you go on GitHub, we've got a few of our repos there. One of them is the repo with all the tests in it. I'll have the link to that in the slides. And then GitLab is where we do a lot more of the automation and the CI work that we have. We also have an internal GitLab deployment as well. And that's it.
Elaborate a bit in terms of what do you mean by integrate with kernel CI and collaborate more with LKFT?
Yeah, so one thing that came out of plumbers in Vancouver last year and plumbers in Portugal this year is that kernel maintainers like what they're getting. They like that someone's testing more often. That's valuable. But I think the challenge is that 7 or 8 CI systems are better than 0, but 1 or 2 would be better than 7 or 8. And so now the request from kernel maintainers has been work together and have the communication not be like a whole bunch of separate emails that come in different ways with different formats, but standardize on something. So that way, more of the data comes through in a unified way. Does that make sense? Because I think also too, like if we run LTP and somebody else runs LTP the exact same way, there's value there, but there's also not value there. So it's one of those things we have to talk about.
So it's more in terms of alignment with respect to what gets fed into the kernel developers. What about kind of maybe a particular CI has more test coverage compared to the other? I mean, are there means to probably share test assets across or build assets across? Is that something discussed?
For sure, yeah, and that's something we argued about in Portugal as well, because there's some test suites that have flakier tests in there, and it would be a lot better if we could say, hey, is anybody else seeing this test being really flaky? And everyone says, yeah, it drives us absolutely crazy. Then that's a great point for us to stop and go to the community that owns that test and say, look, we're finding problems with this, and here's the specific things with logs that we're finding. How do we find a solution? Let's see. I don't know if there's another microphone. Oh, Dan, you got it. I think all the way to the back.
Thank you. I had the impression you do a lot of work on patches that actually come to Red Hat. So those are things that have already been accepted by a maintainer and already upstream. You said a little bit about patches that come to mailing lists, but I would like to know a little bit more in general what you do to help the maintainer.
Right. So we kind of have two jobs. One is inside of Red Hat, we do a lot of testing as well. And so inside of Red Hat, we do use mailing lists to submit patches, and maintainers go and review them, and they get merged. And it's a very similar process to upstream. So we go in there and provide those reports as quickly as possible to the internal maintainers. But then also for Linux stable, NetNext, RDMA, and I'm missing one other one. SCSI. We're doing testing, and we have not started sending emails to NetNext, SCSI, and RDMA, but we want to soon. What we've mainly been working in stable to get the workflow working correctly. So Greg and Sasha have been super helpful at telling us what's good and what's not, and we've been refining that process, and so now we want to start taking it to more upstream kernels.
Okay, thank you.
So what kind of ARM platforms are you testing right now? One, and the second thing is, as a developer, how can I get my tree tested with your stuff? Can we do it right now, or?
Sure. So how do you get your test integrated with us?
So I get my tree tested with 0-day right now, and can I get my tree tested with your stuff as well, like right now?
So integrate the output of your test or the result of your test is what you mean?
So yeah, I want to get automated testing for my setup, my tree,
Oh.
and can you help with that right now, or it is only for some trees right now?
Yeah, no, if the tree's available out on the internet, that's something we can definitely work. Just catch up with me afterwards and we can do that. And then remind me of the first half of your question.
ARM platforms you're using right now?
So right now, the platforms that we do use in our internal environment they're a little bit older. They're not exactly optimal for testing the latest and greatest stuff that's coming out right now. I don't know what the plan is for that, but that's a shortcoming we want to improve upon.
But you're doing build testing for all ARM configs?
So we use the Fedora configs. So we're not doing like we're not building all the configs for like single board SBCs and things like that. We're just building a server-based config for the machines that we have. What else? Any other questions? All right, well, cool. Well, thank y'all.